Hello everyone, welcome to this video. In this video we'll be talking about more results on permutations. So we were studying about odd and even permutations. So in this video we'll be looking at particularly the inverse of those odd and even permutations. So the first result here tells us that inverse of an even permutation, that is also an even permutation. So let's try and prove the result. The proof is very simple here. We first of all assume P to be an even permutation, right? And we will prove that the inverse of this, which we denote by P raised to power minus 1, right? This thing is the inverse, and we will prove that this is an even permutation, right? Now because this is an inverse, so therefore when we compose the permutation P with the permutation P inverse, we would have the identity permutation with us. And in the next video we'll be studying about a result which states that the given identity permutation, that is always an even permutation. So as for this video, you just remember this thing, that this epsilon, the identity permutation, that is an even permutation, and moreover P, so we know this is an even permutation. Now moreover we know that this P is also an even permutation. So what can we say about this P inverse, right? So in the if you remember, in the previous video we have discussed about this result, about the product here, the product of two permutations, that would be an even if either both of them they are even or both of them they are odd. So in our case this is even, so that means either both of them has to be even or both of them has to be odd. So in our case P is even, so that means P inverse has to be an even permutation as well, and this is what we wanted to prove here, right? So the proof is very simple. Let's move on to the second result here. It tells us that the inverse of an odd permutation, that is an odd permutation, right? So that is the proof here is also very simple. In this case we assume we assume this P to be an odd permutation, and we have to prove that P inverse, P raised to power minus 1, which is the inverse of this permutation P, is also odd, right? Now because P raised to power minus 1 is the inverse of the permutation P, so when we compose P with P inverse, we would have the identity permutation, and we already know this identity permutation in even in nature, this P is given to be odd. So by the result that we already know, the product is even. In this case the product is, which is the identity permutation, this is even when either both of them they are even or both of them they are odd. So in our case this product is even, so that means and P is given to be odd, so this means P inverse has to be odd in order to satisfy this thing. So odd into odd would give us even, or we have another condition that even into even would give us again even, right? So this is the result. In our case P is given to be odd, so therefore P inverse has to be the odd permutation. So I hope you understood this result well. That is it for this video. Thank you for watching.